In this video, we're going to look at real zeros of polynomial functions and how that relates to their graphs. We're also going to use a little bit about in behavior to help sketch these graphs. Okay, so some things important to know about a zero is, if C is the zero of P, then X equals C is the solution of the equation when you set it equal to 0. X minus C is a factor, and C is an x-intercept. Now, the biggest takeaway here is, if you know, in my opinion anyway, is if you know a factor, then you also know a zero. And if you know a zero, then you also know a factor. So let's start with thinking about I'll do it. Instead of C, let's use a number. So if X is equal to 2 is a 0. Okay, well, that's a y-intercept, or sorry, x-intercept. It's not a y-intercept. But then also, if I subtract this over, I know X minus 2 is a factor. And so this relationship is very important, that if you know a zero, you know a factor. If you know a factor, you know a zero. And so when we look at these problems in this video, we're going to say, well, if I want to find the zeros, I'm going to find the factors. So we're going to factor how we know how to factor. So if you that's another thing. If you're not sure how to factor, we're going to go through that quickly in this video, but you probably want to seek some outside practice, look up some how to factor videos, or try to, contact me and I can maybe help you out. But so we'll go through these factoring kind of quickly. This is the AC method. So two numbers that multiply to -4 and add to 3 are +4 and 1. And so that means this is positive x plus 4 and x minus 1. I can use the shortcut because 1 is in front of x squared. And then I can find the zeros by setting both of these equal to 0. This is the good old zero product property. But if these multiply to 0, or if this whole thing is equal to 0, I'll use that shortcut if you'll allow me. Then that means x plus 4 must equal to 0, or x minus 1 is equal to 0. So that means x is equal to -4. And x is equal to 1 are the two zeros. Now, if I were you, I would try to get to, and we will in this video, we're not going to show this step, eliminate that step and just be able to jump to here. That'll save you some time on some of these questions that will take longer eventually. Okay, so the multiplicity of zeros. Multiplicity, it's a nice, fun word to say. But this is the number of times, for lack of a better word, we're going to say number of times the zero occurs. And we'll see an example of that later in the video, and it'll make more sense. But for now, let's just think of multiplicity as the number of times it shows up in the function. If the multiplicity is even, then the graph will bounce off the x-axis. And so multiplicity tells us about the behavior on the graph. So what that would look like is, if this were your coordinate plane, if you had an even multiplicity, then it would bounce off and go here. This would be an even multiplicity and go the other direction. If the multiplicity is odd, then the graph will go through or pass through the x-axis. And so what that means is, say, we'll just keep going with this polynomial. Say it bends back down and goes like this. So this 0 has an even multiplicity, and this 0 has an odd multiplicity. And so it's one way you can kind of determine the behavior of the graph, what it's going to look like, or an approximate idea of what it's going to look like, by looking at the zeros and the multiplicities. Okay, so let's look at a couple examples where we're finding zeros and then just talking about the graph. And then we'll look at a couple where we actually graph. Let's see, we're not going to do, okay. Okay, so here, these are all going to factor. So these are the difference of two squares. So this is x squared plus 4, and then x squared minus 4. And then this is the old double factor, which can be tricky. This is the difference of two squares. Again, not here, x plus 4, but then here, x plus 4, and then x minus 4. Okay, so let's talk about the zeros. So if I set each of these equal to 0, here I would be taking the square root of a negative number. So this would be x squared is equal to -4. So that's not real. So there's no 0 that comes from that. Oh, I did put 4 instead of 2. Hopefully you saw that mistake already. Those should both be 2. But then x is equal to 2 and x is equal to -2 from setting both of these equal to 0 and adding or subtracting 2 over. And the graph's behavior, the multiplicity is just 1. These zeros only show up one time, so it will pass through. We're just going to say multiplicity of 1 and multiplicity of 1. And that means they will pass through the graph. Here we have 4 terms, so we're going to hope this factors by grouping. If not, you'll have to use synthetic division, but I bet this factors out. Take it out of -1. And so that gives me x minus 1 and then x squared minus 1. And once again, this is something you can factor twice. Let's put this up here. So we have x minus 1 and then x minus 1 and then x squared, or x plus 1, sorry. You could also write this as f of x is equal to x minus 1 squared and then x plus 1. And so this is what the multiplicity of 2 would look like. So because there's 2x minus 1s, x equals 1 has a multiplicity of 2. And so you would bounce off the graph there. And then x is equal to -1 has a multiplicity of 1. Okay, and then we'll look at 2 examples where we're actually going to sketch the graph. And so here's what we're looking for when we sketch. I'm not worried about the max number of extrema. We're going to talk about the end behavior though, and then we're going to find the zeros, the x-intercepts, or the zeros, or the roots, you could say, and then also the y-intercept, just to kind of make our sketch neat. The other thing you can do is, I'm not going to, take a graphing calculator from you. So you can check this in your graphing calculator. You can check this with Desmos. Just make sure you can do all these things. Okay, so in behavior, let's start there. So as x goes to infinity, on the right, the graph is going to go up because this is a positive leading coefficient. And then on the left, the graph is going to do the opposite because my degree is odd. So odd means the opposite. So it's going to go down. So this graph is going to go up this way and down this way. So that tells me something. My zeros, let's see if we can factor by grouping. And we'll kind of just shift that over here. So take out an x squared and then take out a -1. And so then I can factor that way. My x is kind of bad there, sorry. And then that's a difference of squares, so I can make it x plus 1, x minus 1 from here. And that makes my zeros x equals -2, x equals -1, and x equals 1. And they all have a multiplicity of 1. So they're all going to pass through. So I can put these in my graph, -2, -1, and 1. And then the last thing, just to get the sketch, is the y-intercept. That's just by plugging in 0. And you get -2, 0, 0, 0, -2. Okay, so to sketch this, once again, like graphing calculator, great, you sketch it from there. But we're not going to go up and down to where it exactly is. So this will be a sketch or just an approximation. So it's going to be going down on the left, we said. And so it's going to be going down this way. It's going to come up through here, and it's going to go through that point. At some point, it's going to turn, go through, and then go back through again. And it'll look like this because we know it's going to go up on the right and down on the left. Now, we did not find these values. You could approximate them by plugging in some numbers. There's some other things you can do. We're not going to worry about that. Okay, so try this one. Don't let the format fool you or trip you up too much. It's just already factored for you. So it's already factored. Pause the video, try this one on your own. Okay, so set each factor equal to 0, and you get x equals 0. And this has a multiplicity of 3. Here you get x is equal to -1, multiplicity of 1. And you're looking at the exponents. So this is 3. And this is 1. Oh, sorry, that's actually 2. So x plus 1 occurs twice, multiplicity of 2. And then x equals 2 has a multiplicity of 1. Okay, so those are all of your x-intercepts. We can go ahead and put that on the graph. So 0, 0, -1, and 2. Now, one thing that's handy, just, we got to do end behavior still, I know. But the y-intercept, sorry, this is p. Oh, let's just rewrite that, sorry. When I plug in 0, we get 0. Is 0, 0? And you could plug in 0 and multiply it out, but you already see it, right? You already had an x-intercept in that spot. Okay, so now we need to talk about end behavior. So on the right and left, what happens? On the right, because this is negative, it's going to go down to -infinity. And on the left, which I forgot my negative here, on the left, it's 3, 4, 5, 6 is the degree. So you don't have to actually multiply them out. Just look at the exponents and count them all. There's x to the third times this would be x squared. This would be x to the first. And add those together to get 6, which is even. So it's also going to go down. And so we have this idea it's going to go down and down over here. And then at -1, we have a multiplicity of 2. And so it's going to bounce off of that because it's even. And then at some point, it's got to turn back around and get through this one at 0. And it's going to go through that because the multiplicity is odd. And then it's going to go, so at some point, turn around and go through 2. And it's got to go through that because the multiplicity is odd. And that will also make my end behavior work out okay. So if the end behavior matches what it should, then there's a good chance you got your bouncing go through right on the zeros. If you mess up the bouncing go through stuff on the zeros, your end behavior will be wrong, more than likely anyway, unless you kind of make the double mistake. So just be aware and check that. And also, you can check these on a graphing calculator. I encourage you to do so. That's a good tool for you, or use desmos.com. But good luck and reach out if you have questions.